And chapter 9 is about pavement design. And chapter 9 is the chapter which is most like your other civil engineering classes, right? It's most like, looking at the loads, finding the loads, and then thinking about the deflection or the pavement damage that might create. And then and here, usually, that idea of factor of safety and all those things kind of come into play. Again, we're not going to do the full scale roadway design or pavement design in this class. We'll learn the basics. We'll learn about the design criteria, how to estimate the design criteria for pavements. But as I said, this is most like your other civil engineering classes where you're looking at, okay, really the physics of it in a lot more ways. Okay, so let's get started. So in terms of, and again, that in section 9.1.4 is going to be your reading assignment for that. So go ahead and read that when you get a chance. One thing that is very important for pavement design is you have to know what kind of material you're building your pavement on, right? So what's the sub-base material? What's the base material? And we measure that by looking at the elastic properties of the soil. It's called expressed as MR. It's called modulus of resiliency. Modulus of resiliency is it changes over time, over the time of the year. So in the winter weather, it's going to be different than in the summer weather. And usually, as you would expect, if you're trying to build a pavement on which your large trucks might travel and things like that, and then if you have gravelly soil, that's a good thing, right? If you already have gravelly soil, that's wonderful. If you don't have gravelly soil to build the pavement, then you will need to import some gravelly soil, and this kind of can lead to some cost. And as our guest speaker had talked about, depending upon where you're sourcing your material from, that would change the cost of the project. So again, if you don't have gravelly soil, you have to import that kind of soil to make sure that you are using that as a base to improve the pavement strength. If you have basically organic soil, that's not where you want to build your pavement because that's going to have damage pretty quickly there. So the clay or basically organic soil is unsuitable. So there are two different types of pavements that we talk about. There are two different types of pavements. One is the rigid pavement. It's made of Portland concrete cement. It acts like a solid plate, distributing the load evenly. And then the flexible pavement, which is more of asphalt. It's made of asphalt concrete and it flexes under load and adjusts to the limited differential settlement, right? So there are two types of pavement. Now, both of these pavements have specific applications. In some cases, rigid pavement is a preferred alternative. In some other cases, flexible pavement might be the preferred alternative. Both have their advantages and disadvantages. The rigid pavements, they have good durability, they have very long service life, they can withstand repeated flooding and surface water without a lot of deterioration, right? So that's your rigid pavement. Flexible pavement, they can be easily repaired, so very cheap to repair. You can add additional thickness over time. The non-skid properties, they don't deteriorate. So what happens on the rigid pavements is that over time, their coefficient of friction becomes less. So what happens is that then people start to get having trouble stopping on those rigid pavements sometimes, concrete pavement. So but that's not the case with the asphalt pavement. They retain their skid properties over time. Quieter and smoother, because on the rigid pavement, what happens is that you're connecting different plates. So as you transition from one plate to the other, there is some noise that comes in. And then asphalt pavements, flexible pavements can tolerate a greater range of temperature. So if you know that you're going to have a wide variation in temperature, maybe you ought to look at the flexible pavement. What are the downsides of each? They may lose a non-skid surface over time for the rigid pavement. They need even subgrade with uniform settling. And then they may fault at the transverse joint. So basically where you're connecting the plates, that sort of is the weak point of the pavement. That's where they tend to fail. And then, so that's why you have to kind of take care of the joints a lot of times. So you have to take care of the joint. You have to do a frequent You have to do frequent joint maintenance on those roads. On flexible pavement, you lose some flexibility and cohesion with time. You do need to resurface that much sooner than the PC concrete. But it's cheap to do, but you have to do it more often. Not normally chosen where you expect a lot of water. So if you do put them anywhere, you have to make sure that you have good quality drainage. And that's where that crown section that I talked about in horizontal curves, comes into play as well. On straight segments, typically will provide that crown section so the water drains to the side. So it's very important there. Now, what are some of the typical applications of these? If you have high volume traffic lanes, that's where you use rigid pavements. If you have so most freeways will have that. Freeway to freeway connections. If you have a major ramp that are connecting freeway to freeway, so that means they will have a lot of traffic. If you have exit ramps with heavy traffic, that's again another place where you would advise rigid pavements. On traffic lanes, auxiliary lanes, on where the vehicles are supposed to be there for a short amount of time, you can put in the flexible pavement. Parking areas will almost always be flexible pavement because rigid pavement is just overkill. Frontage roads, again, much lower traffic than the main line. Highway shoulder will always be flexible pavements, except if you're running some kind of a bus on shoulder type situation where you're expecting heavy buses to run on, like I think in the Bay Area, and they're starting one in Monterey as well, or Santa Cruz, I think. They're doing the bus on shoulder application. And if you're going to have some traffic on that shoulder, then you maybe want to consider, rigid pavement. But other than that, shoulders are always made of flexible pavement. So it's important for you to kind of know these typical applications where we put, and again, these types of pavements, it's very important for us to learn about pavements as a public agency. It's the biggest asset that the agencies have to maintain. So if you think about County of San Luis Obispo, county as a whole, I'm not talking about just the traffic division or anything like that, county as a whole, what's their biggest asset? It's the pavement that they have to manage, right? It's the pavement. The county is pretty, widespread, as you know. It goes from such a long distance, and then there are so many county roads that they have to maintain, and then to make sure that there are no potholes there after the rainstorms, things like that. This is something that's always on county engineers' mind because this is the biggest thing that they're managing. We'll talk about the pavement management in a little bit, but first let's think about the design element that we have to account for in this situation. The design element is called ESAL, ESAL. ESAL stands for equivalent single axle load, right? Equivalent single axle load. So basically what we do is we look at the traffic that's going to be on the road, okay? And we convert that into how much of equivalent single axle or a standardized single axle load is that traffic going to provide to the pavement or going to apply to the pavement, okay? And then we use that as our design criteria for, again, if you have higher ESAL, you'll need thicker pavement. And in this class, we are not actually going to design the pavement. We're just going to learn if you're given a certain amount of truck traffic on a road, how do we estimate the equivalent single axle load for that? And then once you know that's equivalent single axle load, you can learn to design the pavement based on that number in CE 429. So CE 429 is your pavement design class, which is where we sort of pick up that discussion of once you know ESAL, that's going to be there. Then you sort of, based on that, you determine the thickness of the pavement and things like that. So that all happens in CE 429. Now, so the relationship of the damage that the equivalent single axle load ESAL does onto the pavement, it's not a linear relationship. It's more of a fourth power relationship, okay? So again, it's the same idea. I think I showed you a chart very early in the quarter when we were talking about how the travel time increases as you add more traffic to the road. That's also an exponential formula, more like fourth power formula. Even though we approximated that with a linear function in our module 1, I do want to emphasize that this is kind of similar. Like in this case, it's the force power formula. So if you have low easel load for a pavement, right, it doesn't cause much damage. But as the load increases, the damage to the pavement increases using a force power formula. And that's why, because of that, what you will find is that passenger cars or even larger pickup trucks, they do not do as much damage to the pavement as is done by large semi-trucks or buses and things like that. Okay? So those large semi-trucks do much more damage compared to a passenger car, because we define axle, I'm going to talk about that single axle load, to be something like 18,000 pound load, right? And the cars are more like 3, 4, 5,000. So if you can take that ratio of 3, 4, 5, 6,000, divide by 18,000 and do the force power, that number is much smaller compared to when you get into these 18,000, 20,000, 50,000 pound loads. And there the easel becomes much more significant. So we'll talk about how do we estimate that. So what we do is we sort of estimate the damage from wheel loads of various magnitude and convert that into damage from an equivalent number of standard or equivalent loads. Okay, so that's the process that we're following. So there are two different formulas for easel single axle load. So if you have a single axle, we estimate the easel for a single axle is the weight of that single axle, weight that's getting applied on that single axle, divided by 18,000. Okay, so now you can, and you raise it to power 4. Okay, so now think about that, right? If you have a 4,000 pound car, 4 divided by 18 is like 1 divided by 4.5. It's like a little bit higher than 0.2, right? So you're talking, very small number there. And because you're talking about very small, and you raise it to power 4, that's going to be not a lot of easels there, right? So if you're talking about a passenger car, it does not contribute a lot of easels. So that's why even on freeways, cars may be causing all the congestion, but the pavement damage is exclusively from those large trucks, right? Because it's because of this force power formula. And then the trucks sometimes have what we call a tandem axle, like you see over here. So this is, I'm showing you two different trucks, 80,000 pound gross vehicle weight. Both trucks that are shown here have an 80,000 pound load. But this load is distributed different ways. On the steering axle, typically, we'll have 12,000 pound load on the steering axle. And then you have, on a single axle, you'll typically have, equal distribution. So whatever is left out of 80,000, so 80,000 minus 12,000 is 68,000. And that's distributed equally onto the 4 axles. Again, it doesn't always have to be this way. There are trucks that might have 60-40 distribution between front and back and things like that. Like you see here, for example, the 12,000 pound load, and then you have the 68,000 left over. And then out of that, 36,000 is on the front axle and 32,000 is on the back axle. Yes.
So in terms of if we have one of those that's not 80,000 pounds, how do we distribute the load?
Yeah, you will be given how will you distribute that load in the problem, or I will just show you this type of a figure on each axle, or you will distribute it based on, so typically 12,000 will go onto the steering axle, and then you will sort of
into the bottom right one.
Bottom right one, yeah. So
specifically in the problem we have, it's 70,000.
So you're talking about the homework problem. We could probably take a quick look at that.
Do it back to, or are we?
Yeah, so you could. So if nothing is given, a 50-50 is fine. You can do 50-50 if nothing else is given the problem. In some problems, they might be given to you as that. Hey, apply 60% to the front and 40% to the back, and then you use that ratio. If nothing is given, 50-50 is fine to you. Okay. Yeah. Now and then you can see that on the tandem axles, the way the damage works is that you don't, like tandem axle, they don't have the double the load, right? So you it's slightly less than double the damage, right? So you can see that if you're talking about tandem axles, they don't do double the damage. Their ratio is based on 33,200, so they cause a little bit less damage. And then and the tandem axle formulas differ between the flexible pavement or the rigid pavement. So in the problem, you want to be looking for if any of that is specified in the problem. If it says rigid pavement or does it say flexible pavement? If it doesn't say anything, just state the assumption that, hey, I'm assuming a rigid pavement, and that's why I'm applying this formula. Or if I'm assuming flexible pavement, I'm applying this formula. If I'm using the rigid pavement, applying the appropriate formula that way. Okay, so these damages depend on what kind of axles you're talking about and what type of type of pavement you're talking about, flexible pavement or the rigid pavement, because they just behave differently. So their equivalent damage is calculated differently. So the standard load for a tandem. So if somebody asks you, hey, what's the standard load for a tandem axle on flexible pavement? That's 33,200. What's the standard load for a single axle? It's 18,000 pounds. And then on tandem axle on rigid pavement, the equivalent load or the standard load is 29,000. Right? So this is equivalent standard or equivalent single axle load is what you're talking about. So we'll solve an example problem in just a second, but let's talk about first like pavement management systems. Pavement management systems, as I said, the pavements are the largest capital assets where local governments are responsible. And local governments are responsible for even larger, much larger pavement assets compared to even Caltrans, right? Because Caltrans will typically have, if you think about the length that they manage, Caltrans will have some freeways and things like that, some state highways, some state routes. But if you talk about counties, they manage so much more pavement. So it's very important for the local agencies. Pavement management includes all activities, planning, design, construction, maintenance, and rehabilitation. And required information that you need to be able to do that is pavement type, pavement performance, road type, past activity records, like when was the last rehabilitation done on a certain pavement and things like that. We'll talk a little bit about the pavement performance, how the pavement is performing for the drivers. That is the kind of data you need. And how do we collect that data? How do we define it? We define pavement performance using I should correct this a little bit. This should be called present serviceability index. This should be called present. PSI stands for present serviceability index, PSI. So the current value of that, and the way they measure PSI is kind of interesting, is that it's very subjective in nature, although you have trained experts, but the way it works is that you will have folks just ride on that pavement at a certain design speed or certain speed at the design speed level, and then they will basically rate the pavement performance, like how was the ride, was it comfortable and smooth and whatnot, and then you take an average of a few experts based on an opinion from panel of experts, and then you average that, and then you'll get your PSI, present serviceability index. So if the pavement is too damaged, then typically the PSI value will tell you that, hey, you need to, and then all pavements have something like, if the PSI goes lower than this, then you have to rehabilitate that pavement or do some repairs on that pavement so that you can bring up the PSI. So that's based on the opinion of panel of experts. Nowadays, because it has become a little bit easier to do so, the modern measures are becoming more quantitative in nature. Okay, the modern measures are much more quantitative, and those measures are IRI. It's called International Roughness Index. That's one of them. The way this is that you install an equipment on your vehicle that you're driving, and that the way it gets attached to the pavement or attached to the vehicle, and it touches the pavement as you drive on that road. And as you're driving on that road, it estimates how much up or down the equipment is moving per mile. Okay, so you typically measure it in terms of inches per mile, how much inches of vertical deviation you got, the absolute value of the vertical deviation you got while you're driving on a certain segment. And then, the larger the variation, that means you had not a smooth ride. Smaller that variation, smaller that III number, that means you had a smoother ride, right? So you estimate that using inches per mile. A lot of time you're looking at friction measurements. That's there, especially on the rigid pavements, because you want to make sure that the drivers are able to stop on that roadway. So it's a safety concern. So friction measurements is useful. And then there are different types of pavement damages, and then you are physically measuring the rut depth. And I want to quickly show you different types of pavement damages, although you do talk about that in CE 322, I think, where you're looking to measure different types of pavement damages, and you're looking for that on the pavement. But I want to just quickly show you that, although it's covered in CE 322. So I want to quickly show you different types of pavement damages. And then you're basically just measuring those damages in the physical environment. And that's also the very important part of your pavement management systems. So you can see these different damages here that you're seeing. So you can see the alligator cracking, longitudinal cracking, potholes. Number E is rutting. So this is the kind of rutting that you see. And then you are basically going out in the field and measuring this type of, using this type of equipment, measuring, how much rutting is happening on that. Basically, where the wheels are, that's where the damage happens. And then, if you have repeated, the pavement has not been repaired over time, this becomes much, much more severe. Okay. So yeah, you're doing these physical quantitative measurements to define the damage on the pavements rather than just relying on the opinion of the experts. So there's more modern measures, or modern measures are much more quantitative in nature, so that you can make apples to apples comparisons where there is more damage. Yeah, I think knowing these types of pavement. So if you work for an internship at a county, for example, this might be your whole job, is just kind of trying to go out in the field and looking at pavements and looking at and identifying different types of damages that may have occurred on the pavement. So that's a very, very useful lab that you may have done in CE 322, I believe. Yeah, again, we don't talk about that in the lecture portion in a lot of details, but just wanted to give you that example of how rutting is measured in figure 929. See. Okay. So what I want to do next is I want to look at some example problems that is like the problem you solved in, like the problem you solved in, or you're solving in the homework. So let's look at that. Let's look at a few examples here. So let's say if you have a truck like this that is shown in figure 9.5, and you want to calculate how much easel does it contribute, that one truck like this would contribute. So the way you do it is that you look at, okay, I have got so these are all single axles, right? Because they're all single axles, what I'm going to do is I'm going to use that 4th hour formula, 12,000 divided by 18,000. So I'm basically looking at this truck, and I'm trying to calculate the easel damage of figure 9.5, truck shown in figure 9.5. So it'll be, let's take a look at how would I calculate that? It's going to be 12,000, right? This and the damage caused will be 20,000 divided by 18,000 raised to power 4, right? So that's your easel here. You will get your calculator to calculate that, and then you add to that 17,000 over 18,000. Right? Raised to power 4, right? So that's going to be the damage caused by one of these axes. This is just for this axis. And then you have identical 4 axles just like this, So all you'll need to do is multiply that by 4. And that would be, you can use your calculators to then calculate the easel damage or equivalent single axle load for that just one truck. Okay. Now, in the problems that you will see, maybe in the test or homework or whatever, I might say that, hey, there are 500 trucks like this that travel on this roadway every day. Okay. So let's say there are 500 trucks. Let's say there are 500 trucks like this every day on the pavement. If that is the case, how much is the annual easel that will get applied on that pavement? It'll be, so annual value of equivalent single axle load would be 500 times 365 times the easel value that you just calculated. Does anybody have the easel value for this by using the formula that we just did?
10.38.
30.38. Okay, so I'm going to trust you here. 30.38. Is that what everybody got? 20?
3.
Just 3?
3.3.
3.3. Okay, is that right? Okay, so that sounds good. So 3.38 is sounds about right. So 500 trucks every day, 365 days in a year, and then every truck has an easel value of 3.38. So if there are 500 trucks like this, then you can compute the total easel value. The annual value of easel would be this number here. Does anybody have that for me? 500 times 365 times 3.38. How much? Right. Okay. So that's going to be your easel annual value of equivalent single axle load that will gonna get applied. And then we use this number in the pavement design to come up with, how much thick, how much pavement would you need? How much thickness would be of different layers of pavement and things like that. So let's look at some other problems here. Yeah, so they 3.38, they just rounded it up to 4. That's fine. And let's look at if you have tandem axle, right? If you have tandem axle like this, for this one, they do exact same thing. 12/18 for the single axle front, and then you have 36,000, 33.2, 33.2. Now, here, when you apply this formula, you're making one more assumption, as I said before, right? If you're using this 33,200 formula, that means you're basically assuming that you're analyzing the easel for the flexible pavement. So this calculation that you see for this type of a truck, it's for flexible pavement because you're using that 33.2 in the denominator. Okay, and again, you could see, so this is one tandem axle, this is the other tandem axle, and you're computing the damage. You can see that the twin tandem truck does a little bit less damage because the equivalent single axle load for that is only 2.44 rather than 3.38, right? So because of the tandem axle, it's just doing a little bit less damage to your pavement compared to the 2S12 truck that you showed before. Now, each of these trucks have certain names, right? So 3S2 is what this truck is called. 2S12 is twin tandem truck. Now it has the name tandem in the truck, but there's no tandem axle. So just remember that tandem just kind of is there for these two things here. It's called twin tandem truck, but there is no tandem axle on the twin tandem truck. So just make sure that, again, I'm not going to ask you, I'm just going to give you the design of the truck. I'm not going to have you remember what each of these different types of trucks look like, and so forth. But you should be able to look at this configuration and be able to estimate the easel values for each truck or the annual value if needed as well. Let's see. If there were rigid pavement, the tandem axle would be 29,000. So that's good. And then, we use the fourth power formula, and then this is the result of that fourth power formula. If you sort of do that, you can see that the damage just exponentially increases. The easel value, as the axle weight increases, the easel value just kind of explode there, right? So just want to make sure that you see that. And again, you won't have to remember any of these names. If I give you a truck like this, I'll give you the load distribution in each of these trucks. And then I'm not going to have you deal with the growth formula either. So I will not be dealing necessarily with growth. I'll just have you kind of stop at the annual single axle. You can just figure out the annual load. You can, if there were a growth percentage given that the trucks will grow by 2% or whatever, you can apply this formula, but we're not going to worry about that. I will not go beyond having you estimate the annual ease. Okay, just like we did in that slope. So you'll be good there. Okay. So you could see. So for example, for a multi-lane freeway, example 9.1, there is 2,000 trucks a day. Okay. For design purposes, we should assume that the trucks are operating on the outside lane closest to the shoulder. 800 of the trucks are empty, contributing about, 0.25 easels per truck. So they've already given you the easel for the empty trucks. So that's right here, 800 empty trucks. They already give you the 0.25. And then you can calculate the total easel per day, just multiplying 800 by 0.25, okay? But then there are different types of trucks, 3S2 of different weights, okay? 80,000, 70,000, 60,000, and then 2S12 trucks, 80,000, 70,000, and 60,000. GVW stands for the gross vehicle weight, okay? So that's your GVW right here, okay? 80,000 pounds, and this is telling you how they're distributed. So 12,000, remaining axles have to 34,000, okay? And then same thing, 12,000, 29,000, 12,000, 24,000. So if you add them all up, you will get your 80, whatever the total load is on, right? So 12,000, and then this one doesn't show you the figure, right? So in the problem, they just show you 3S2 and 2S12. I might give you a table like this, but I'll always show you a picture of what that truck looks like. Okay, so if I give you 3S2, you will know precisely what 3S2 looks like. 3S2 will look like this, right? So 3S2, so this is 2S12, this is 3S2 right here. Okay, and in this case, they give you that the load on each of the axle is exactly the same. Okay, so 3S2 is 12,000 and 24,000. So then you have 12,000 on each of those axles like that. So just make sure that you see that. So that the load on the front and the back axles are equal in this case. Okay, on each of the remaining axles. And you will not worry about how the load is distributed on this last one because they give you already that the easel is already 0.25. So you're not going to worry about that. And then you can compute the daily easel by multiplying individual trucks easel and then multiplying that by the number of trucks. So this times this gives you this. This 0.75 times 300 gives you 2.25%. Yeah. So they show you that formula for each of them. So they're saying like equal 34,000 equal into two axles. So 17,000 divided by 33,200. You compute that and then 0.1975 plus 2 times 1.099. So you can verify any of these computations and calculate your annual easel based on that. So let's look at one of these numbers and make sure that we can derive it, right? So let's look at this one, 2S12, 70,000, and daily traffic is 200. Let's make sure that we can derive this value right here. I want to be able for us to derive this value. The 2S12 type of truck, let's compute the easel value for each truck. And then the daily traffic is 200. So use that information to get to 200 times 1.88 is 376. But I want to make sure that we can derive that 1.88 is the new thing we just learned, right? So let's take a minute You'll need to know what 2S12 looks like, which I'll give you in the problem. But for now, we can just go back up and see what 2S12 looks like. The 2S12 will look like this. Twin tandem truck, 2S12, 12,000, and then you'll have whatever is left on the other trucks. The 2S12 looks like this. Let's look at that problem again. What was the load? It's 70,000 one we're working with. 12,000 goes from the single axle, and then remaining axle will have 12,000 and then 14,500, right? So 14,500 times 14,500. You know where we are getting that 14,500 from, right? So gross load is 70,000, right? So 70,000 is the total minus the 12,000 on the steering axle. You're left with 58,000. And that's going to be equally distributed onto these four axles. So 58,000 divided by 4 is what you're doing here for a 2S1 truck. So 4 times. So your formula will become 12,000 divided by 18,000, right? Raised to power 4. Plus, what should I do next? 4 times what? Let's do it on your sheets for a second, and then we'll come back and talk about. So 12,000 by 18,000 raised to power 4 is the easel for the steering axle, and then 4 times 14,500 over 18,000 raised to power 4 is something for the remaining axle. So this will be 14,500 for all 4 of them for a total of 70,000. And then tell me what that number looks like. We get 1.88. That's good. So we were able to verify how we can estimate the load there, the easel value for any given truck. And then now one thing that happened here is that we multiplied. In the previous example we did, I just basically took the annual value multiplied by 365. Sometimes the trucks are assumed to be having, different patterns, like, if your trucks only run like 6 days a week or whatever. So they use some different numbers in the example. I think they use something like 6-day weeks or 50 weeks per year by excluding holidays for the annual loads. But again, that depends on what assumption you're making in terms of trucks. Do the trucks not run on holidays? I don't know. I'm not sure. So again, that is an assumption that you could make, that your trucks are only running 300 days a week, or are they running for 365 days a week? That will be an assumption. If you do make it one way or the other, just make a note of that in the solution. In the licensing exam, typically you will be given precisely what to use. So just make sure that you use how do you compute the annual loads from daily loads. And then we are not going to go to the growth formula here at all, although it's not very difficult, but I just typically tend to, I'm not a fan of applying a simple growth for 20 years, because in 20 years, things do change a lot, right? So our delivery mechanisms might change, and, so 20-year prediction horizon is